Okay, guys, so I'm going to do a quick wrap-up lesson from 5.1b. So on Thursday, we finished up 5.1b, at least half of it. So today we're going to go over the remaining half. So really quick recap of 5.1b is that we learned how to factor trig expressions. So the goal would be that I'm going to be able to verify trig identities. Basically, the skills that I need to verify include factoring, they include adding fractions, they include knowing my identities, and they include just kind of using your creative solving skills. So, what we're going to do today is just kind of build on that. So, first thing, we learned how to factor trig expressions. We realized that, hey, when I factor a trig expression, it's really the same thing as factoring a traditional expression. For example, secant squared theta minus 1, that's really the same thing as me saying something squared minus 1. If I take secant to be s, it's s squared minus 1. S squared minus 1 is actually really easy to factor. It's a difference of squares. And so what I get is s minus 1 times s plus 1. And if I replace back, I get secant theta minus 1 times secant theta plus 1. So just kind of keep that in mind. If you do feel confused about this whole factoring thing, please don't hesitate to reach out and we can go ahead and do a recap on that. You can always use your box method and your, your X method. All right, so one other thing, recap, we talked about adding and subtracting trig functions. If they're fractions, they work the same way as a normal fraction. A normal fraction needs to have a common denominator. To get a common denominator quickly, I can multiply the first by the denominator of the second and the second by the denominator of the first, always in one form. So same thing over the same thing. I don't want to change the expression. Lastly, we talked about, hey, how can I rewrite something so it's not a fraction? We talked about how I'm not allowed to do this thing I'm going to highlight right here. How I'm not allowed to cancel 1 and 1. If I think about like my favorite animal in the whole world in baby form, think about that animal. I don't even know if I want to say it on if I want to say it on video, but something bad happening to the animal anytime that you do that. So I give you that example just to kind of keep it in your brain. I know that things like shock you sometimes keep that memory in your brain. So remember here that we introduced this idea of conjugate. So a conjugate is basically just like the opposite sign of a binomial. So for example, if I have x plus 4, its conjugate is x minus 4. If I have x squared minus 10, its conjugate is x squared plus 10. If I multiply the top and the bottom by the conjugate of the denominator, I end up getting a difference of squares, creating 1 minus sine squared. 1 minus sine squared using Pythagorean identity is the same thing as cosine squared. So I'm able to rewrite something in non-fractional form by using conjugates and by using what I know about the reciprocal identities. All right, so I know that was a really big recap. Let's go ahead and do something new. All right, so something new here. Actually, it's kind of really not that new because we've done composite functions before. What we're going to do is find f of g of x. So if I think about composite functions, I know in the past we've said composite functions are like a sandwich. So like f of x, that's like the bread, and g of x is like the eggs in the middle. So like if I'm making an egg sandwich, f of g of x is a sandwich with bread on the outside, eggs on the inside. If I had g of f of x, then g of f of x would be like eggs on the outside, bread on the inside. I don't know if you've had a sandwich like that before, but it would be interesting to try. So let's go ahead and evaluate this composite function. First thing I'm going to do when I evaluate composite is I'm going to replace what's in the middle with what I know. So g of x is 3 sine of x. So I really want to find out, hey, what's f of 3 sine of x? Really what this is saying is anytime I see an x in the f of x function, I want to replace it with 3 sine of x. So 3 sine of x needs to be replaced for x in both instances. So let's go ahead and rewrite this. This is going to be equal to, not in highlighting form, it's going to be equal to the square root of 9 minus, well, instead of saying x, I'm going to say the inside function. I'm going to say like the eggs on my sandwich. That's going to be 3 sine of x. And notice how x is squared here, so I'm going to have to square this. Really quick, I'm just going to do a little bit of simplifying. This is going to be 9 minus 9 sine squared x. So this is going to be 9 minus 9 squared x. Well, if I take a 9 out, if I factor a 9 out, I get 9 times 1 minus sine squared x. And hopefully our trig brains are really ringing a bell right now, because 1 minus sine squared x, I've come across this in the past. In fact, I think I did it right here. 1 minus sine squared x is cosine squared x, isn't it? That's by a Pythagorean identity. And so what I get here is that this is the square root of 9 times, using Pythagorean identity, 9 times cosine squared x. Cosine squared x. So using properties of what I know about square root functions, I can actually rewrite this as the product of the insides. And the reason I'm allowed to do that is I'm separated by multiplication. If this was addition, absolutely do not do that. Think about the baby animals. Don't do that. So we can actually rewrite this as 2 square root functions. I'm going to have the square root of 9 times the square root of cosine squared x. Well, the square root of 9, that's easy. Square root of 9, hopefully, is 3. And when I think about inverse functions, and I know we did a lesson on this the other day, what undoes a square? A square root. So if I have the square root of technically cosine of x quantity squared, a square and a square root cancel each other. And so what I'm left with is that this expression is 3 cosine of x. And you will be seeing at least one of these problems on your web assign. So go ahead and make sure, if this is confusing for you, maybe take a pause and look at this again. All right, let's move on to the next. So what we're going to do next is we're going to do something called logarithmic differentiation. Oh my gosh, I'm talking about calculus. We're going to do logarithmic trig functions. But in order for this to work, I'm going to have to do a recap on logs. Just in case we don't know how logs work, there are 3 basic rules for a log. So once again, if you're not really familiar with what a log is, if I graph what a log is, specifically what is a natural log. So a natural log is the same thing as like a log base e. The natural log graph looks like this, while the e to the x graph, and I didn't graph that very well, looks like this. If we go back to what we know about inverse functions, when I flip them across the line y equals x, they are the same image. They're reflections. And so inverse functions, the inverse of the exponential function e to the x, its inverse function, is natural log of x. So basically, natural log of x and e to the x are what undo each other. So just kind of keep that in mind there. And if you're really confused about even what logs are in general, we might do another recap video just altogether separately. So let's go over the 3 rules for logs. So a natural log is the same thing as the log base e. There are some rules with logs. If I have the log of, let's say I have the log of m plus the log of n. That is the same thing as the log of m times n. So we can see that if there is addition on the outside, it is equated to multiplication on the inside. Now, it does not work the other way. So if I said log of m times log of n, that is not equal to the log of m plus n. That does not work. So it only works one way. If there's addition on the outside, that is multiplication on the inside. The next rule is this. We'll do division. If I have log of m minus log of n, that is the same thing. And let's think, okay, addition is usually connected to multiplication. Subtraction is connected to division. So this is the log of m divided by n. Okay? And now there's one more rule of logs, and hopefully this is a review, and if it's not, we will definitely do another lesson on this. Just let me know. The last one is this. If I have log of m to the n, that is the same thing as me saying n log of m. So what I can do in essence is if I have a power that's on the inside of a log, I can move it to the outside of the log. So these are the three basic rules for logarithms. So let's go ahead and see if we can use the rules of logarithms to simplify trig expressions. First one, natural log of cosecant of theta plus natural log of tangent theta. Okay, I see addition on the outside, which is the same thing as multiplication on the inside. So I'm going to rewrite this. Natural log, ln, of the absolute value of, we'll say there's addition on the outside, that's multiplication on the inside. So I'm going to say cosecant of theta. Oops, not do that right. We'll say cosecant of theta times tangent of theta. And I want to simplify this some more. Cosecant of theta is the same thing as 1 over sine, and tangent of theta is the same thing as sine over cosine. So let's rewrite this. I have 1 over sine of theta times sine of theta over cosine of theta. So I can see that sine of theta is in the numerator, sine of theta is in the denominator, and so these are going to cancel because this is separated by multiplication, not addition. And so what I get is the natural log of 1 over cosine of theta, which I could rewrite as the natural log of the reciprocal identity, which is secant of theta. And once again, if you're feeling real stuck on how in the world am I pulling up all of these reciprocal identities so quickly, you can go ahead and use the reciprocal identity sheet as a reference sheet. And so that's on Google Classroom if you want to use that as a reference. You can also just Google it. All right, next one. Natural log of secant plus natural log of sine theta, same thing. We're going to say that this is the natural log of addition on the outside is multiplication on the inside. So we'll say secant of theta times sine of theta. Well, secant of theta is the same thing as 1 over cosine. So this is going to be natural log of 1 over cosine times sine of theta, technically over 1. If I multiply these through, I get sine of theta over cosine of theta, which is the same thing as tangent of theta. So this is how I can use properties of logarithms to further simplify expressions that have trig functions and log functions in them at the same time. That's pretty much it for the lesson today. If you have any questions, please feel free to let me know. Really, if you could let me know if you need to do a mini lesson on log, I would love to hear it. And that's it for today. I hope you guys have an awesome day. See ya.